Bismillahirrahmanirrahim. Dear viewers, now we are going to start 3-storied building design course. First of all, we will make column layout plan according to the architectural plan. So this is ground floor plan. Copy this one. This is first floor plan. Okay. Now we will draw preliminarily two column size. One is at 0.2 meter, that means 20 centimeter by 0.4 meter, that means 40 centimeter, and another column will be 20 by 50. As per different country practice or different court practice, this width of column may vary to 20 centimeter or 25 centimeter or 30 centimeter. So according to the requirement, we will provide the column width. Here, for example, we are going for 20 centimeter column width. So here 20 by 50, 0.1 we will stress, so that it will be 50 centi. Now we will hatch the column. This one we will mesh with this hash. To get the column more visible, we are doing hash, solid hash, and outline we will mesh with the column layer. Here you can see some layers. This is column layer. Always better to use different layer for different structural members. So now this column we will put in our architectural plan. So copy this one. Better to provide column in first floor, so that we can match with the typical floor above first floor. Copy it to here. We can rotate this column to this side also. Now this one, copy here. As this column in this direction, so this one we will rotate. So that this span will also be reduced and this side span will be adjusted. If I keep this column in this direction, then this side beam will be very small and this side beam will be very large. And here, as we have bathroom or toilet, so better to provide another column here, so that this beam we can take it down to provide pipe inside the bathroom. So copy this one. Like this. Now as here we have provided this column here, so now this span reduced. So in this case we can rotate this column this direction also. But for reducing slenderness effect, I will provide one this direction, another 90-degree angle to reduce the slenderness effect of the building. Now here I will check how much the span size, 7.2 meter. It is your wish. If you want to reduce this span, then you can add here or here. So better to use here. So here I provide this one for stair. I provide here and here like this. As the stair is finishing here, I'll try to put this column here. This one is here. Okay, now here column, as here two toilets, so we can put another column here so that this beam can be taken down to provide plumbing pipes easily. In this case, if we make this beam little bit down for provision of pipes, there will be no requirement for cutting core inside the beam for pipe. Cutting beams and columns is very dangerous for structure, so always better to avoid cutting inside the beams and columns. So this we have provided. Now in this side, here we can rotate this column to reduce our beam span length in this direction. Copy this one and here to here. Okay, now this column we can make it in other direction, and here we can provide one column. Copy this one, provide here. Then here we can see in this position one beam and here one beam, so we will try to cover both the beam on the column. So this is our this side column layout plan. Now this side, copy this one. Remember that for low-rise building or this type of 3-story villa, we are providing columns almost all the beam intersection point. For high-rise buildings, symmetrical column layout is provided for structural safety and to prevent the lateral load effect. This one I'll put here like this. This one we can rotate to reduce this span length. Okay, like this. This one we'll copy here. Here we can see this column we cannot rotate because here is door, so we have to provide this column here in this direction. Now here we will check this span length 7.8. Better to provide another column here. Provide same here. You can provide this column here also. Different structural engineers may have different approach, so these things are depending on your choice and structural judgment. Now this is okay. Here provide this one like this. So this is our column layout as per our first floor plan. Now this column, this layer I will isolate so that we can filter all the columns only. Then copy this one, we will put in ground floor and we will check if there is any problem or not. Here you can see this here. So only one column is making problem, that one, this. So this one we will rotate. Better to rotate here, because here we have beam end line. Now copy this one from here to here. This one delete. So this is our column layout plan. Now we will make beam. Before that we have another floor. This one. Second floor plan. Here also we will put our columns. So this is also okay. Now we will copy terrace floor plan. Here we will copy our columns. Like this. Here this column did not copy it because this is not in column layer. This match with this, and this has will match with this. Now this one I will copy. Now here we can see this, here is opening and here open terrace. That means here in this floor there is slab, but in terrace floor there is no slab. So these two columns will not be here, and this one also will not be here. So here what we can do, provide one column, like it is called floating column, from this floor level to this floor level. This floor is finishing here, like this, like this. So here after this there is nothing. This is showing opening like full. In reality this line also will not be seen. This will look like this. Okay, in reality it will look like this. So our column layout for all floors finished. Now we will draw our beams. So we will start with first floor. This beam to hold this first floor walls. So this beam will be on ground floor roof. Okay, so according to our wall layout we will provide beam. So here remember two approach. One approach is we will provide beam under all the walls, and another approach is we can provide beams only connecting the columns. For example, here if we don't provide beam, then we have to design this full slab area considering this wall load and this much bigger span. In that case this wall load will be transferred to slab, then from slab to adjacent beam, then from those beam to columns. Here if we provide beam, then this wall will provide, or this wall will give load to this beam, then from that beam it will be transferred to adjacent beam and columns. So now here we will follow the wall layout to provide our beams. First we are drawing single beam line only, then later on we will offset the lines by 20 cm. Here we will provide beam width 20 cm. So now I think all the single lines finished. Here like this, like this. Now we will create offset. O enter 0.2, that means 20 centimeter, 0.2 meter. Done. Here on balance this one. Like this. Now here we can see here is wall, so here we can provide beam, and alternatively we can provide extra bar here. If we provide beam, then this slab area will be divided into two parts. If we provide extra rebar like this 0.1, like this 3y 14 or 16 millimeter die bar at top and bottom for providing more stiffness to hold the wall. Now here usually we follow this provision to consider this as a full slab, and inside this full slab there will be extra bar. Same here we will do 0.1, here also we will do. In this portion we can keep beam. Here we can provide another beam like hidden beam, offset 50 centimeter width hidden beam. Now here one slab, and here we can provide landing, and this will be as a landing support at floor level, and here in mid landing we will provide another beam to hold the mid landing. Now this is our beam layout plan. Now this beam layer we will isolate. Copy this one, we will paste here. We want to see if there is any issue in ground floor level or not for this ground floor roof beam layout. In this type of low-rise residential building, clients don't want to see any beam hanging inside the rooms. So here we can see in ground floor this is full family hall. In ground floor there is no wall, so this beam will be seen from ground floor as a hanging beam. So this beam we cannot provide in first floor level. Here what we will do, we will provide hidden beam. In thumb rule, normally if it is 5 meter, we provide hidden beam width 5 meter into 0.2, we multiply as a thumb rule to provide hidden beam width. So 5 into 0.2, that means 100 centimeter. O enter 1 meter. 100 centimeter equal to 1 meter. So this is hidden beam here, so that we will not see hanging beam from ground floor. If you have question what is hidden beam, I am making clear here. For example, this is the floor, this is the hanging beam, then going like this. This is the slab. In the edge there is wall. Here there is wall. So but at ground floor, here in this position there is no wall. So from ground we can see this beam is hanging. So to avoid this offset from slab, or to avoid this odd looking beam, we can provide hidden beam like from here to here. We can take this one like this, and as hidden beam width is more than hanging beam, so it will be like this, and the hidden beam depth is lower than hanging beam. Usually we take it from 35 cm to 45 cm as per the analysis demand. Now this is hidden beam, and how it is working I'll show. I'll draw another line here, this slab will be taken bottom of this beam. Fillet this hidden beam, and this slab also will be taken down like this. Now we can see here so this is the hidden beam, and this is the slab connected at the bottom of hidden beam. Now here we can trim this one also like this. Now from down we cannot see any hanging beam. At floor level, as we can see, there is offset. To remove this offset, what is done, this level we have to provide sand filling. This one. Here we will provide like this. So here this portion will be filled by sand, then on top of this there will be floor finishing and tiles, so that top also it will be plain and bottom also will be plain, so there will be no hanging beam. For this reason we have to provide hidden beam where there is no wall bottom at that beam. So here we have provided hidden beam. This hidden beam also provided for this reason, so that from ground floor we cannot see that beam. Here we will provide clean beam. This line we will delete. In ground floor level, as we will provide clean beam, so there will be no extra rebar for absent of slab, RCC slab. In ground floor there will be no slab, only plinth beams. Offset 0.2, this one, this one. Okay, now ground floor beam layout, first floor beam layout, finish. Now this one again isolate, copy from here to here. First floor plan, second floor plan. In first floor there is wall, so here no need hidden beam. We can provide drop beam here. Okay, although it is open terrace, but bottom of this slab there is wall, so we can provide this beam. If there is no possibility for future extension, then we can remove this extra rebar. If there is any possibility to extend this portion, like here in future they can make bathroom and wall to make one room, so for that future provision we can keep this extra bar and beam. So now this is done. Top of the second floor roof, how it will be, we will copy, here as there is no column on that side, so we have to take reference point here to here. Now this portion we will delete. Delete this one. This extra line here also it can be offset like this. In all the side we can provide 20 centimeter slab, 20 centimeter cantilever slab, so that it can fulfill the architectural requirement. Now here, as this is terrace floor plan and this is second floor roof, above this floor there will be no extension, so this extra rebar we can delete, 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 like this. Here this 2020 size column, if it fails in analysis and design, then we will provide here larger column. Now this is done. Now we will take this column and beam in our structural report. Okay. Ground floor roof beam, that means first floor roof, that means second floor, and second floor roof means terrace floor. So this is our beam and column layout plan, which is ready for going to the next steps. So thanks for watching. Stay tuned for getting next tutorials. If you have not subscribed yet, subscribe the channel and press the bell button to get notification when we will upload new important tutorials, and like the tutorials if you are being benefited by this, and share these tutorials with your friends and colleagues.
Press the bell icon on the YouTube app and never miss another update.